Hello, this is question 11 on your June 2018 paper 1 from Edexcel, and you have to use binomial expansion to show that this expression here can be approximated by this one. We have one binomial to the power of 1/2, so let me show you. So you have 1 plus 4x divided by 1 minus x all to the power of 1/2. You know how to expand 1 plus something to a power, and we are going to use the adjacency formula because this is not a natural number but a real number. So remember, you have two formulae. So let me show you. This is for natural numbers when the exponent is a natural number. This one is for real numbers, so we have to use this one because n is 1/2, which is not a natural number. We need a 1 and something. The thing is that we cannot expand the bracket, we cannot expand this fraction. If we try to divide, we are not going to get a binomial. So the way of doing these questions, and I think if you don't know, it's going to be difficult to think. So what we are doing is to expand the numerator and to expand the denominator. But we are going to write the denominator with negative exponents so we can multiply them. Yeah, so we expand this binomial, we expand this binomial, and then we just multiply because they are two polynomials. So if we expand this binomial, we have, just using the formula, that this is going to be 1 plus n1. N is your exponent, nx, sorry. So 1/2 x is your 4x altogether. Then n minus 1, so 1/2 minus 1 is minus 1/2, divided by 2 factorial, and then 4x squared. And we don't need anything else than squares because we have maximum power here is 2. Yeah, so I'm not going to carry on. Then I'm going to expand the other one, so I'm going to expand 1 minus x to the power of minus 1/2. This is going to be 1, n is minus 1/2, x is minus x, then the next term is going to be n, so minus 1/2, times n minus 1, so minus 3/2, divided by 2 factorial, and n is minus x in this occasion squared. We can write the first one, so I'm going to just find or simplify the coefficients. So for the first one, I have 1, and then I have 4x divided by 2, 2x positive, so plus 2x. This one is going to be negative for this minus here, and I have 1/2 times 1/2 divided by 2 and multiplied by 16. So you can do all that with a calculator or on your head if you don't get mistakes. And this is minus 2x squared. And for the second one, I'm going to do the same. So I'm going to simplify the coefficients. I have 1, and then I have minus 1/2 times minus x is positive 1/2 x. And again, I do minus 1/2 times minus 3/2 divided by 2, and is going to be positive, which is 3/8 of x squared. Yeah, and I don't need to write more because I'm going to multiply. So my answer is only up to x squared. And now I'm going to multiply. So if I want to carry this thing here, I'm going to write the first bracket is 1 plus 2x minus 2x squared, and the second bracket is 1 plus 1/2 x plus 3/8 x squared. Again, I just need to get x squared, so I'm going to start multiplying this one by all that. So this is 1 plus 1/2 x plus 3/8 x squared. Then I multiply 2x by this and by this, but I don't need to multiply by this one because I would get x cubed, and I'm not interested in the x cubed. So 2x, and then 2x times 1/2 x is x squared only. And then I'm going to multiply this one only by the 1, because when I multiply by the next one, the x is to a greater power, so just minus 2x squared. And I just simplify, I collect like terms, so I have 1, and then I have 1x plus 2x, which is 5/2 x, and then the x squared is 3/8 minus 2 plus 1, so minus 1. And this is minus 5/8, no? 5/8 of x squared. I can write that would be better if we write that is just the approximation, yeah? And that's how we prove, and in fact they give us the expression already, so we just have to check that we get the same, yeah? That's for A. Then for B, and a student substitute x equals 1/2 into both sides of the approximation shown in part A in an attempt to find an approximation to √6. Give a reason why the student should not use x equals 1/2. So remember when we do an approximation when n is a real number and not a natural number, this approximation is valid only in a set of numbers. So is when this absolute value of this is smaller than 1 and absolute value of this is smaller than 1. So my approximation is valid when absolute value of x is smaller than 1 and absolute value minus x is smaller than 1. Yeah, so it has to satisfy, I'm expanding this one, so this one is smaller than 1, I'm expanding this one, so this absolute value is smaller than 1. And in this case, this means that absolute value must be smaller than 1/4. Smaller than 1/4 and smaller than 1 is smaller than 1/4. And 1/2 is not smaller than 1/4, which means the expansion is not valid. Yeah, so I cannot use that value. Expansion is not valid. Then substitute x equals 1/11 into the expression to obtain an approximation to √6. Give your answer as a fraction in its simplest form. So if we substitute 1/11 here in the left hand side, we have, so root of, what was it? 1 plus 4x, so 1 plus 4 out of 11, because I'm multiplying by 1/11, 1 minus 1/11. So I do this, and I get root of 3/2. Yeah, that's my left hand side. And my right hand side is just substituting 1/11 here. So if I substitute there, I have 1 plus 5/2 multiplying 1/11, which is x, minus 5/8 multiplying 1/11 squared. When you do this, you get 1,183 and 968. So we need to approximate √6 using this thing. So I know that √3 divided by 2, so the left-hand side can be approximated by this. But I need √6. So I need somehow to find √6 here. So what I have is a fraction. I can multiply by 2 and divide by 2 to have an equivalent fraction. And that way I will have √6 divided by 4, just multiplying the fraction by 2, numerator and denominator. Which means that √6 is going to be, if I divide √6 by √4, is divided by 2, so I can multiply the 2 here. So √6 is approximated by 2 times 11964, which is this number here. And I would always check that this value here is really similar to √6, because you are approximating √6 and you can get √6 with a calculator. So this value, just you don't have to write anything, it's just for you to check. So this is 42444, and √6 is 2.449, which means we are very close, and the answer is very likely that is correct. If you get here 10.4 or something very different, that means that something is wrong. I hope this step is clear. So just to clarify, so you have √6 divided by 4 is √6 divided by √4, which is √6 divided by 2. Yeah, that's why I multiply. To find √6, I multiply this value by 2. Yeah, that's all with this question. And this is the approximation that you're looking for.